So the interval where this function is differentiable, which will also be the domain of the gradient function. So remember, we're looking for where the function is continuous and smooth for it to have a gradient. So we'll see straight away that function's certainly not continuous. Okay, and there's a break at -5. So therefore, we know that it's going to be all real numbers apart from -5 where it's not continuous. There's also going to be no gradient if it's not smooth. So we'll see here if we look at this part here. This part is not smooth, okay, at x equals 2. Now a smooth gradient, a smooth part of the function is where there's a gradual change in the gradient. So the gradient you see here, the gradient here is -5. And then at this cusp, the gradient goes to 0 and starts to increase. So there's no gradual change in the gradient from -5 to 0. Okay, so whatever it is anyway, right? So -2 to 0, right? But there's no gradual change. So therefore, at 2 here, you're not going to have a gradient. So there's going to be a gradient everywhere because it's smooth and continuous everywhere apart from -5 where it's not continuous and it's not smooth at 2, therefore there's no gradient there. So that would be the domain of the gradient function also. Alright, so looking for values of x or where there's a negative gradient. So we can see here that there's a negative gradient in this section here. So it's going from -infinity up to -5. Okay, so, and as we say, there's not going to be a gradient here. Okay, so it's certainly not going to be negative. And then we get another section here where the gradient's negative. This section between 0, not including because the gradient is 0, and 2, and it will not include because there is no gradient there. So if we look at C here, where the gradient's positive, so obviously this section here is going to be a positive gradient. So it's going to be from -5 up until 0 here. And we do not include 0 because we know that there's a 0 gradient there. Or this section here at 2, but because there's no gradient at 2, we certainly don't include that. And then going up to infinity. Where the gradient 0, there's this part here. So here it's going to be at x equals 0. Will be your only point where the gradient is 0. So next part, find the value of c. So we're either moving this up or down. There's 4 solutions. So if we move it up, we're certainly not going to have 4 solutions. We're going to have 2 solutions here and then 1 solution here. So we're basically going to be moving it down. So you see here we've got 1, 2, 3 solutions at the moment. So if I move it down, I'm going to have 1, 2, 3, 4. If I keep moving it down, I'm going to have 4. But if I move it down 4, then I'll have 1, 2, 3 solutions, you see. So basically I need to move it down between 4. Okay, so moving it down 4, but not including 4, will give me the 4 solutions. So the answer is going to be -4 to 0, but not including -4, because if you move it down 4, you're going to have 3 solutions. If you don't move it down at all, you have 3 solutions. So any little bit less, then it's going to be 4 solutions. So that'll be our answer.